Alright class, today we're going to start out with a few notes about work. We're starting a unit on work, energy, and power. We did a worksheet on it a couple of days ago while I was gone. We did it with the sub. So here are a few notes about work. Work is a way of transferring energy. Force is the agent of change, and so work is equal to force times displacement. Displacement is a vector, and force is a vector. However, work is a scalar, which shows magnitude only. If work is done, the object has to move. That's important. If you are just standing there holding a chair up in the air or a box up in the air, you are not doing work. Even though it feels like you are not. There has to be a displacement. If work is done, the displacement must be parallel to the force. Work is equal to 0 if force is perpendicular to the distance or the displacement. Force is measured in newtons. Distance is measured in meters. So work is a newton meter for a unit, which has a special name called a joule. Now you can, if you're watching this at home, you can stop this video at any time in order to catch up with the notes. I'm going to pause it here in class so that you can catch up with the notes, and then we'll go on. Alright, so let's look at work and work done by a variable force. So the first problem is you slowly lift a book a mass of 2 kilograms at a constant velocity, a distance of 3 meters. So you have a free body diagram here. Force of gravity is acting on the book. So your work is going to be equal to force times the distance moved. Since it's being moved up and down, you're actually working against the force of gravity. So you've got to, it does not give you the force in the problem, but so you've got to find the force to plug it in. And so you're going to be looking at force of gravity is equal to mg, which is 2 times 10 is equal to 20 newtons for the force. And so you can plug in 20 here, and the displacement that it's moved is 3, and you get that the work is 60 joules. So we're starting off with a really simple problem there. Number 2. A 15 kilogram crate is moved along a horizontal floor by a warehouse worker who's pulling on it with a rope that makes a 30-degree angle with a horizontal. The tension in the rope is 69 newtons and the crate slides a distance of 10 meters. How much work is done on the crate by the worker? So we're going to draw a picture. It doesn't ask for a free body, so I'm just going to draw a picture. Obviously we have an angle here. We're going to need this to split that up into its components. So we have an x component and a y component. There's our angle. So this is FT, cosine would be adjacent. And remember, the force that is parallel to the motion is the one that we're looking at. So we have FT cosine theta will be our force. So our work is F times displacement, force times displacement. Our force is going to be the FT cosine theta, because that's the one that's parallel to the motion. And then we have our displacement. So we can plug in our numbers. It said our force is 69. It makes an angle of 30 degrees. And our displacement is 10 meters. So you plug that into the calculator and you get that work is equal to 600 joules. Number 3. In the previous example, assume that the coefficient of kinetic friction between the crate and the floor is 0.4. How much work is done by the normal force? So we take a look at this picture right here. We have a force of gravity. We have a normal force, and it wants to know how much work is done by the normal force. Well, if you'll go back to the notes, the displacement must be parallel to the force for work to be done. The box is actually sliding this way. It doesn't say whether it's going at a constant velocity or it's going with an acceleration. So it could be A or V, but the thing about it is moving towards the right. It is not moving up and down. So there is no work done by the normal force. How much work is done by the friction force? So we add in our frictional force right here. Our frictional force is equal to mu times the normal force. So according to our sum of our forces in the y direction, Fn minus Fg is equal to 0. So Fn is equal to F of G, which is equal to mg. So our force of friction is going to be mu mg Our mu is 0.4. Mass was 15 kilograms. And gravity is 10. We plug those numbers in there, and we get 0.4 times 15 times 10 is equal to 60. Newtons. So then we go and we find the work, which is the force times the displacement. Here we're looking at the frictional force. So we're going to have 60 times the displacement, which we go back and look at the previous problem, was 10. So our work is 600 joules, and we need to note that the frictional force is in the opposite direction of the motion. So that is actually going to be a negative 60, which is making that a negative 600. That is a negative 600. And had I done forces in the x direction, I would have seen that sum of the forces in the x direction equals force of tension minus force of friction equals MA. And so my force of friction is definitely negative here. Now we look at number 4. A box slides down an inclined plane of 37 degrees. The mass of the block is 35 kilograms. The coefficient of kinetic friction between the box and the ramp is 0.3, and the length of the ramp is 8 meters. How much work is done by gravity? So I can draw me a quick picture here. So there is no push or pull here. It is coming down by gravity only. So we have FG. Oh, sorry, that should be signed because it's opposite the angle. Whoops. FG sine theta. Over here is FG cosine theta. So for this box to come down this ramp, in the x direction, we are going to be looking at the FG sine theta for our force. So if we look at the sum of the forces in the x direction, we have FG sine theta is equal to MA. So that is our force right there. So work is equal to FG sine theta times the displacement. We change F of G to mg. So work is equal to mass times gravity times sine of 37 degrees. And that equals 1,690 joules. There. Now it wants to know how much work is done by the normal force. The normal force is in the y direction, perpendicular to the inclined plane. The box is actually moving in the x direction, so work is 0 because the force is perpendicular to the distance, or the displacement. I need to use displacement and not distance. Distance is a scalar, displacement is a vector. How much work is done by friction? So if we have a frictional force here, and we do, again we have that the frictional force is equal to mu Fn. If we do the sum of the forces in the y direction, we have that Fn minus Fg cosine theta equals 0. So that means that Fn is equal to Fg cosine theta. So we plug that in, mu times Fg cosine theta. So we're going to use 0.3 times mass, 35, times gravity, times cosine of 37 degrees. That's going to equal 83.86 newtons. Then we can find our work. Force of friction times displacement. 83.86 times 8 meters. And that equals 671 joules. Again, that is in the opposite direction of the movement. So it's going to be a negative. So that force of friction is a negative. And that is our answer right there. To find the total work done, all we have to do is add up all the work. So total work is equal to the work done by gravity plus the work done by the normal force plus the work done by friction. Let's make that a little f. And so we just plug in our numbers. 690 plus 0 minus 671, and that is going to equal 1,019 joules right there. Now our last problem is going to be a graphing problem. A spring exerts a force as shown on the graph below. How much work is done as the spring stretches from 20 to 40 centimeters? So work is equal to force times displacement. You can see here we've got a force on this side, displacement over here, or sometimes it's called position. And so we are actually looking to look for work. Work is going to be equal to the area under the curve of a force displacement graph. And so we can split these up into triangles and rectangles and use area. So I'm going to split this up right here. I'm going to make this a triangle. So here the area is going to equal 1/2 base times height. Here the area is going to be length times width. Well, I keep breaking my pencil. Length times width. So area 1, 1/2 base times height equals 1/2. My base from 20 to 40 is 20. My height is from 40 to 80, so 40. And that is going to equal, that's going to make that 10, so 40 times 10 is 400. And then my area 2 is going to be equal to length times width, which is 20 to 40 is 20. Width is going to be 0 to 40. 20 times 40 is equal to 800. So then we add those together. It's going to be 800, 900, 1,000, 1,100, 1,200. But then remember we need to, and that's going to be in centimeters, so we have to change that to meters, and so that's going to be 12 Newton meter, and I'm sorry, that would have been a Newton centimeter. Newton centimeter, here it's a Newton meter, which equals 12 joules. So there's your answer right there. So now you are prepared to do a little bit of independent practice. And remember to look at your notes and the problems I've done to do that. Thanks.